This lesson we are going to learn how to use inequalities to express regions. And before that, let's briefly review how to express a straight line. First, normally we just draw the xy coordinate system and mark the axis and the origin. And how do we graph the line y equal x plus 1? We learned before, first we should mark its intercept. So it means it starts from the y-axis as 0.1 and with slope of 1. That means for every unit increasing x, y increases by 1. And this way, we draw the whole straight line. And now let's graph y equals 2x minus 1. So still we start from its intercept, from the starting point of the y-axis. So it starts from 0, negative 1. And its slope is 2, which means for every unit increasing x, y increases by 2. So this straight line will look steeper, go as this way. And now let's graph a special case, a negative slope, which we haven't encountered before. So y equals minus x plus 1. So still it starts from y-axis as 0,1. But the slope means for every increasing x, y increases by negative 1, or in other words, y decreases by 1 unit. So this straight line goes downward with a slope 1. And how do we find the intersections between those straight lines? Let me just mark the name straight line 1 and straight line 2. How to find their intersections? A. As we learned before, point A lies both on straight line L1 and L2, so it will definitely satisfy two equations, y equal x plus 1 and y equal 2x minus 1. So it will satisfy both equations. And they share the same value of y and x, which means we can substitute any one into the other equation. So let me try to substitute the second one into the first one. 2x minus 1 equals x plus 1. So x equals 2. And when I substitute back of the value x, I would get y equals 3. So the coordinate of A would be 2, 3. And that's how we solve simultaneous equations, and that's how we find the intersections between two curves or two straight lines. We combine them and solve the simultaneous equation, because their intersection will definitely satisfy both of the equations of the two graphs. And let's consider the special lines that we mentioned before, x equals 1. So what does it represent? So it means a vertical line. Wherever x coordinate on it, it's 1. So which line is at y equals 1? So it's a horizontal line where every point y coordinate is 1. So the intersection of the two straight lines is point A, which is 1, 1. It means its x coordinate is 1 and y coordinate is 1. And before that, we have also shown that in different dimensions, say in one dimension, x equals 1 is a point on the axis. And in two-dimensional world, like in 2D, x equals 1 is a straight line. And in three-dimensional world, like in our real world, it means a plane. So that's we have shown before. And we need to talk about something more, like the inequality. So what does it mean for x is greater or equal 1? Still we make the xy coordinate system. So x is greater or equal than 1 means you need to draw this vertical line first, and every point on the right side of the line, their x coordinate is greater than 1. So it basically means the whole area, the whole region. And so conversely, x is smaller than 1 means the area on the right side, on the left side. And for y equals 1, it means a horizontal line where every point on this line, their y coordinate is 1. And for y is greater than 1 or equal to 1, so see, basically every point on this above the straight line, the y coordinate is greater than 1. So it means the whole region. And for y smaller than 1, it means the region behind it, under it. And let's see another special example, y equals x. So drawing the x or y coordinate system, it means a special line that passes through the origin with a 45-degree inclination. It means every point on the straight line has equal x and y coordinates. But what does it mean for y is greater than x? Let me just give you a point. 1, 1 is on the straight line. And 1, 2 and 1, 3 or 2, 3, you can obviously see that every point above the line, they have a greater y coordinate than the straight line. So this inequality actually means this region is above the straight line. And for y is smaller than x, so you see every point under the straight line, they have a smaller y coordinate compared to the points on the straight line. So it means this area. And so we could describe regions in shading areas by inequality. And let's just do it conversely. First, you can try to draw the region defined by y is greater than x, and x is smaller than 1, and y is smaller than y as well. So let me just try to take them. First, let me draw this line, y equals x. And for y is greater than x, so it means every point above the straight line. So it means this area. Let me take this in yellow lines. So it means above the yellow line, this area. And for x is smaller than 1, let me just first draw x equals 1. And for smaller than 1, it's all the area is on the left side of the straight line. And it should interact with the yellow area. And let me do y is smaller than 1, so let me just try to draw y equals 1 first. So it means this area. And it's smaller than 1, so it's under it. But considering their interaction, so it only has the part like I have drawn in this red area. So this is what we're looking for. And let me erase the other parts. So when you solve it again, this red area, it means y is greater than x and x is smaller than 1 and y is greater than 1. Oh, this might look quite weak. And then let us do another example. So y is greater than x and x is smaller than 5 and y is smaller than 5. So still we start with the xy coordinate system. And then we do a straight line y equals x. And for y is greater than x, it means the area above the straight line. And for x is smaller than 5, and let me just first draw x equals 5 and y equals 5. So it should be on the left side of the vertical line and on the down side of the horizontal line, and it's above y equals x. So if you take their common region, you will find the shaded area would be here. the red region. So that's how we express regions using inequalities. And there is another trick. So try to define this area. Let me just give you. It's a square area. The small trick is it has 4 sides, and we could treat it as it has 4 elements. So 4 elements will correspond to 4 inequalities, which are independently x is greater than 1, but x is smaller than 2. So we could write them together as this. And y is greater than 1, but smaller than 2. So this is this class. We have learned how to express regions inequalities, and it's quite important because we will test this a lot on exam papers, and it's a very essential skill, and hope you can master it. And see you next class.